Hi everyone, and welcome to the first video on the recurrent neural network section. So basically, this section is about deep neural networks that are used to process sequences, right? And typically, the variable in these sequences is time, so we'll usually refer to it as time. But it's good to keep in mind that the sequence could be anything. So the index of the changing variable in the sequence need not to be time in particular. So a sequence like, for example, received samples of an audio waveform, images in a video, samples of a received wireless communication signal. All these time really means time, but you could also have other sequences like maybe DNA sequences where the sequence, the index doesn't refer to time. So basically these networks, so you could use a normal convolutional neural network even for these sequences, but the idea is basically to do parameter sharing over time so that you can capture long-term dependencies, right? So basically the idea behind recurrent neural networks is the basic idea is very simple. And the basic idea is that basically at every time instant, the value of the output or the value of the state of the network as a function of previous and future inputs, because maybe it's not only just I'm capturing dependencies backward in time, maybe also forward in time. So there is a variant called bidirectional recurrent neural network where it goes both ways. So that function is the same regardless of the value of the index itself. So in signal processing, there is this feature that's called time invariant systems. You could think of it as similar to time invariant systems. Basically, it means that if you shift, so it's similar also in convolutional neural network, the equivariance property, which basically if you shift the input, the output shifts with you. So here you can think of it the same way. The value of the state of the system or the output as a function of the previous inputs and the future inputs and the previous states and the future states, this is the same function regardless of the value of the index itself, right? So this is basically the mechanism of parameter sharing over time that recurrent neural networks are using, and there is a slight variation that's called recursive neural networks. Later in the section we'll discuss what it is, but at this point I want you to keep in mind that these two refer to different strategies for building the neural network architecture. So they are both used for sequence modeling, but what's called a recurrent neural network is different from what's called a recursive neural network. Most of the discussion will be on recurrent neural networks, but there will be one video on recursive neural networks. And basically the difference comes from this parameter sharing mechanism. So another key feature of recurrent neural networks is processing sequences that may have variable length, right? So not all the sequences have the same length. A related idea that existed before the current form of recurrent neural networks is what's called time delay neural networks. And basically the idea of time delay neural networks is to concatenate the inputs corresponding to different time steps and to apply convolution over features or elements of the input vectors corresponding to different time steps. But because actually one essential feature of convolution is sparsity, so usually you apply it only on few of them, right? So it doesn't capture really the long-term dependencies that recurrent neural networks does with the computational efficiency that the recurrent neural networks do, right? So if you want time delay networks to capture long-term dependencies, you would need to have large convolutional kernels. But because of the parameter sharing through time that happens in recurrent neural networks, we are able with a relatively computationally inexpensive way to capture very long-term dependencies. So dependencies between inputs that are far apart in terms of the time index. Right? So in the starting from the third video, it will be clear how basically this parameter sharing through time happens, or what we mean by it, and also the statistical assumptions that are implied by different architectural designs of recurrent neural networks will be something that we will highlight throughout this section, right? So this last comment here basically is explaining what I was just saying, that in recurrent networks, each output is a function of previous inputs, of previous outputs, possibly is a function of not only previous but future outputs in bidirectional recurrent neural networks, and that function is the same function from one time step to the next, right? So that's what results in this parameter sharing over time, which results in a very deep computational graph, right? So even though the network is simple to describe, the computational graph that results from this network can be very deep. And to further digest or to realize what happens to the computational graph when we do parameter sharing over time, we will need to discuss in the next video the concept of unfolding the computational graph, and that's where we will start in the next video. Thank you.